Good afternoon. My name is Hans H. Stein. I'm a professor in nutrition at the University of Illinois in Urbana-Champaign. And I'd like to talk to you today about some recent advances in the use of distillers dried grains with solubles, or DDGS, in the swine industry. The outline for the presentation is that we will start talking about energy digestibility and concentrations of digestible and metabolizable energy in the sources of DDGS that we are currently seeing in the market. We will then talk about amino acid digestibility in current sources of DDGS and compare to what we saw previously in DDGS. We will then talk about growth performance for pigs fed diets that include distillers dried grains with solubles, and we will talk about both weaning pigs and growing finishing pigs. And at the end, we will have a few conclusions. One of the biggest changes we have seen to DDGS over the last few years is that most ethanol plants in the United States now remove some of the oil from the solubles before the solubles are added to the distilled grains. And that means that we get DDGS that has lower concentrations of oil than we used to see. So the definitions we now have is that conventional DDGS contains more than 9% oil, but if some of the oil is removed, then we call it low oil DDGS, and low oil DDGS contains between 5 and 9% oil. And if the oil is removed by hexane extraction, the resulting DDGS usually will contain less than 5% oil, and there are a few ethanol plants in the US that is also using this technology. However, by far the most plants we have now, they centrifuge the solubles, and therefore the resulting DDGS is what we call low oil DDGS with 5 to 9% oil. If we look at what oil removal does to the gross energy in DDGS, we can see on this slide that in conventional DDGS, here with a source that contains 10.5% oil, we have more energy than we have in corn, and also more energy than in the low oil DDGS, in this case with 7.5% oil. And this indicates that as oil is taken out of the DDGS, then we reduce the concentration of gross energy in the resulting DDGS. This also affects the metabolizable energy in DDGS, and we can see here that we have significantly less metabolizable energy in low oil DDGS with 7.5% oil than in conventional DDGS with 10.5% oil. So that means that as the ethanol plants have started centrifugation of the solubles to remove oil, the DDGS that has been produced appears to have a reduced concentration of metabolizable energy. And we will see in this case, both the conventional and the low oil DDGS contains less energy than corn. However, in recent research we've conducted at the University of Illinois, we determined the metabolizable energy in 8 different sources of DDGS. And we'll see here that there is some variability among sources of DDGS. And these 8 sources of DDGS, they were obtained from 8 different ethanol plants. And we can see, first of all, that none of these sources of DDGS contain as much metabolizable energy as corn. So they're all lower than corn. We'll also see that source E in this case had the lowest amount of metabolizable energy, and this source had significantly less energy than source D. But all the other sources were not different from either A or D, and they were not different among each other either. But the point here is that we do have differences in ME concentrations among different sources of distillers grains, as would be expected. The average for ME in these 8 sources was 2,953 kilocalories per kilogram, and this number is significantly less than what we saw 5 or 8 years ago in distillers grains, when we had about the same amount of metabolizable energy in DDGS as we had in corn. So we do believe that the removal of oil from the solubles before the solubles are added to the distilled grains actually has reduced the metabolizable energy in DDGS. So therefore, we have a lower energy value in DDGS today than what we used to see. If you look at amino acid digestibility, things are a little bit different. We determine amino acid digestibility in different feed ingredients as the lleal amino acid digestibility. And the lleal amino acid digestibility is determined using pigs that have a cannula inserted in the distal ileum, and we can then open the cannula and take fluids out from the distal ileum and analyze those fluids and thereby determine what we call the standardized lleal digestibility of amino acids. And this is a routine procedure in our laboratory, and we have used this procedure on many occasions to determine digestibility of amino acids in different feed ingredients. If we look at the NRC for pigs, you'll see that the standardized lleal digestibility of amino acids in DDGS, here indicated in yellow bars, is less than in corn for most amino acids, and in particular it is less than corn when it comes to lysine. So the digestibility of lysine in DDGS used to be less than in corn. We conducted an experiment several years ago where we determined the digestibility of amino acids in 3 different sources of DDGS. In yellow bars, we have here a conventional DDGS that contained 11.5% oil. We had also 2 low oil DDGS containing 7.5 or 6.9% oil here, indicated in the blue and the green bars respectively. And we will see that for all amino acids there was a reduced digestibility in the low oil DDGS compared with the conventional DDGS. And this we interpreted as a consequence of materials moving faster through the intestinal tract if you remove the oil from the DDGS, and therefore there's less time for absorption of amino acids. However, we recently conducted an experiment with 7 sources of distillers dried grains that were collected from 7 different ethanol plants. We have here the average of the 7 sources in the blue bars, and we are comparing that to NRC values in the yellow bars. And we will see that in particular for lysine, we have a greater digestibility in the 7 sources that we collected in 2016 compared with NRC. And also for threonine and tryptophan, there were small increases in the 2016 samples compared with NRC. So it appears that the digestibility of amino acids is greater in the sources of DDGS we have now compared with our NRC values. And this is despite the fact that all 7 sources of DDGS we included in this 2016 work were low oil DDGS sources. If we look at the concentration of amino acids in these sources of DDGS, we can see here that we had more lysine in the DDGS we collected in 2016 compared with NRC. There was not much different for methionine, threonine, or tryptophan. So it was primarily lysine that was increased in concentration compared with previous values. The reason we see this increase in the concentration of lysine, we believe, is because there's change in how much lysine is involved in the Maillard reaction. And the Maillard reaction is a chemical reaction that happens if a feed ingredient is heated in the presence of sugars. And we have both sugars and amino acids in distillers dried grains, and therefore we can have the Maillard reaction occurring if samples are heated at high temperatures. So what happens here is that lysine will be involved in a chemical reaction with the sugars and form a Schiff base, and if more heat is applied, that Schiff base will be turned into amadoric compounds. And amadoric compounds can then be further turned into what we call melanoidins if we apply more heat. Both the amadoric compounds and the melanoidins are not usable for the pigs. So if we change lysine into any of these compounds, we will see a reduction in lysine. What happens here is that in normal lysine, we have an amino group at the end of the side chain that contains 1 nitrogen and 2 hydrogens. However, one of the hydrogens can be replaced by a sugar molecule if we have heat damage occurring. And then we call it unreactive lysine, and that lysine cannot be utilized by the pigs. So if we have amadoric compounds and melanoidins, we will see that there is a reduced digestibility of lysine, and there's also a reduced concentration of lysine because some of these compounds, in particular the melanoidins, they are not analyzed as lysine. So the more lysine that is turned into melanoidins, the lower amount of lysine will be analyzed in the sample. But the important point here is that heat damage will always result in both a reduction in lysine digestibility and a reduction in lysine concentration. Those two always go together. So, if we look at lysine in distillers grains over the last few years, we conducted work in 2004, 2005, and we had about 35 samples of distillers grains involved in that work. And the average analyzed lysine in those samples was 0.78%. We also conducted work from 2009 to 2012, and we had another approximately 35 sources of DDGS analyzed in that period. And we can see here that the average concentration of lysine in those samples was 0.93%. So we had an increase from 0.78% to 0.93%. And in the work we have done over the last few years, we have seen that lysine has analyzed close to 1% or on average 0.99%. So what has happened here over the years is that lysine in DDGS has increased as a percentage of the product. The reason for that is we believe that less lysine has been destroyed via heat damage in the product. However, crude protein has not significantly changed. So if lysine changes and crude protein remains the same, then we see changes in lysine expressed as a percentage of crude protein. In 2007, the average lysine to crude protein concentration was 2.8%. So at that time, we recommended that all sources of DDGS should be greater than 2.8 to make sure we had an above average product. In 2012, the average was 3.1%, and now in 2016, the average was 3.4%. So we can see that lysine as a percentage of crude protein has increased over the years. And again, this clearly indicates that there's less heat damage and therefore less destruction of lysine in the heating process of DDGS now than there was 10 or 12 years ago. So this is a clear improvement of the quality of DDGS. If we go back and look at the digestibility of amino acids in the 7 sources of DDGS we collected in 2016, remember we saw that digestibility of lysine had increased. And again, based on what we saw before, if you have Maillard reaction, you reduce both the concentration of lysine and the digestibility of lysine. So what we believe has happened here is that we have less destruction of lysine in the samples we collect now compared with earlier, and therefore we also have a greater digestibility of lysine. However, it is apparent still that the digestibility of lysine is less than it is of the other amino acids. And under normal circumstances, if there's no heat damage to a feed ingredient, the digestibility of lysine should be greater than the digestibility of threonine, because threonine is usually the amino acid with the lowest digestibility in undamaged feed ingredients. So it appears from this slide that there still is room for improvement and that there still may be some heat damage going on, although at this point there's less heat damage than there was 10 years ago. We recently also conducted some work with a new source of distillers dried grain. This source is called high protein distillers dried grains, and this is produced by Lincoln Way Energy in Iowa. And what this company is doing is they dehull the corn before corn is going into fermentation, and then after fermentation, the solubles are centrifuged to remove oil. And that's how the high protein DDGS is produced in this case. The concentrations of amino acids in distillers grains with high protein concentration are here indicated in blue bars, and we also have conventional DDGS in the orange bars. And we'll see that there are greater concentrations of not only lysine but also all other amino acids in the high protein DDGS compared with conventional DDGS. The digestibility of amino acids in high protein DDGS is also greater than in conventional DDGS, in particular for lysine and for methionine in this case. And we will see here that in this case we have lysine digestibility that is slightly above the digestibility for threonine and quite a bit greater than what we saw in previous experiments, indicating that in this case the Maillard reaction has not destroyed much lysine, if anything, and therefore we have a greater digestibility. And indeed, the lysine to crude protein ratio in this case was 3.8% for the conventional DDGS and 3.76% for the high protein DDGS. And these values are greater than anything we saw on previous samples where we had a maximum of up to 3.4%. So this clearly indicates that there's less heat damage in these sources of DDGS than what we have worked with previously. We also determined the metabolizable energy in the high protein DDGS and compared it with conventional DDGS and corn, and you'll see in this case the conventional DDGS and corn were not significantly different, but the high protein DDGS contained more Me than both corn and conventional DDGS. So it appears that high protein DDGS has a greater feeding value than conventional DDGS. We have now talked about digestibility of amino acids. We've talked about energy concentrations. Now we'll talk about what happens if DDGS is added to diets. In this case, diets for growing finishing pigs from 25 to 115 kilograms. And in this case, we conducted an experiment where we fed pigs from 25 to 115 kilograms diets that were based on either corn-soybean meal or corn-soybean meal plus DDGS. And we fed those diets either without pelleting, so those were in a meal form, that's the first two columns here, or we fed them the same diets in a pelleted form. So we formulated the diets the same, but we had both the control diets, the corn-soybean meal diets, and the DDGS diets fed either as a meal or in pellets. If you look at feed intake from the period from 25 to 115 kilograms, you'll see here that there was no difference between the control diet based on corn and soybean meal and the DDGS diets. And there was also no effect of pelleting on feed intake. So whether diets were fed as a meal or in pellets did not impact feed intake, and whether it was corn-soybean meal diets or corn-soybean meal DDGS diets was no impact on feed intake. If you look at average daily gain, again from the period from 25 to 115 kilograms, there was no impact of DDGS on average daily gain, so whether there was 0 or 30% DDGS in the diets had no impact on average daily gain. However, pigs fed the pelleted diets had slightly greater growth rate compared with pigs fed the diets in a meal form. So we had a little bit greater average daily gain for the pigs fed pelleted diets. The gain to feed over the same period, there was no impact of DDGS on gain to feed. So again, whether we fed corn-soybean meal diets or corn-soybean meal diets with 30% DDGS did not influence the gain to feed of the pigs. However, if we fed pelleted diets, we had an improvement in gain to feed compared with feeding meal diets, which is also what has been indicated in previous research. So the overall conclusion from this experiment is that yes, pigs have greater gain to feed and average daily gain if they are fed pelleted diets compared with meal-based diets, but there was no impact of DDGS on any of the growth performance parameters that we measured in this experiment. So 30% DDGS seems to be okay in diets for growing finishing pigs. We then conducted a different experiment. In this case, we started pigs on DDGS from weaning. So they were fed 10% DDGS in diets, fed the initial 2 weeks post-weaning. Then they were fed 15% DDGS in diets fed from 3 to 6 weeks post-weaning. And then they were fed 30% DDGS in all diets from 6 weeks post-weaning and until market at around 110 kilograms. All the diets with DDGS also contained 10% wheat middlings. So we had really high fiber diets in those groups. If we look at the feed intake here, you'll see that during the weaning phase, and the weaning phase in this case is defined as the initial 6 weeks post-weaning, where we fed 10 or 15% DDGS and 10% wheat midds to the diet and compared that to control diets without DDGS and wheat midds, we saw a reduction in feed intake during the initial 6 weeks post-weaning. However, when we look at the following period, the growing finishing period, we see that pigs fed the DDGS and wheat middlings diets actually had greater feed intake than pigs fed the control diet based on corn and soybean meal. So it appears that although they had slightly reduced feed intake in the weaning period, pigs were able to compensate for that later on when they were fed the low-fiber diets. And I should add here that diets were not equalized in energy. We let the energy float, so as we increased DDGS and wheat middlings in the diets, we reduced the energy in the diet. So there was less metabolizable energy in the diets containing DDGS and wheat midds compared with the corn-soybean meal control diets. And that may be part of the reason why we saw the increased feed intake in pigs fed the DDGS wheat middlings diets. If we look at average daily gain, there was a reduction during the weaning phase from 0.48 kilograms per day to 0.46 kilograms per day. However, during the grow finish period, there was no significant difference between pigs fed a corn-soybean meal diet or a diet containing 30% DDGS and 10% wheat middlings. Gain to feed, in this case, there was no difference in the weaning period, the initial 6 weeks post-weaning, because pigs were eating a little bit less, they were gaining a little bit less, so there was no difference in the gain to feed ratio. However, during the growing finishing period, there was a small reduction in gain to feed, and the reason for that was that pigs fed the DDGS wheat middlings diets, they were consuming a little bit more feed as we saw before, and they didn't gain more than pigs fed the control diet, and therefore gain to feed was slightly reduced for these pigs. But again, remember that the pigs fed the DDGS wheat middlings diets were fed diets that contained less metabolizable energy than pigs fed the corn-soybean meal control diet, so that would be expected to result in a reduction in gain to feed. The final body weight out of the nursery after 6 weeks post-weaning was 26.08 kilograms for pigs fed the DDGS wheat middlings diet, but 27.03 kilograms for pigs fed the control diet. So there was a small reduction in the body weight out of the nursery. However, when we look at the grow finish period and the weight when pigs went to market, there was no difference between the two groups, indicating that pigs fed the DDGS wheat middlings diets were able to compensate enough to catch up for that kilogram they lost in the weaning phase, and at market there was no difference between the two groups. So these data indicate that it is indeed possible to feed DDGS to pigs all the way from weaning until market without reducing the final body weight of the pigs. So a few conclusions that we can take away from these experiments. First, we have seen that the energy value in low oil DDGS is reduced compared with the energy value of conventional DDGS. So the industry today, by removing oil from the solubles, has reduced the metabolizable energy that we have in the resulting DDGS. We also saw that the concentration of lysine, the standardized ileal digestibility of lysine, and lysine as a percentage of crude protein are all increased in DDGS that we receive today compared with the DDGS we used to have. And we believe that the reason for these increases is that the industry today is doing a better job of controlling heat during the drying process of distillers grains, and therefore they don't destroy as much lysine via the Maillard reaction, and therefore they don't reduce digestibility of lysine as much as we used to see in the industry. So we have better digestibility and better lysine concentrations in the DDGS we buy today compared with previously. Some of the limitations to these studies should also be pointed out. First of all, we've seen that 30% DDGS in diets for growing finishing pigs is okay, so we can add that. However, in some studies it has been demonstrated that the dressing percentage of pigs fed diets containing DDGS is slightly reduced compared with pigs fed corn-soybean meal diets, so that should be taken into account when the overall effects of DDGS are estimated. We've also seen that 10 to 15% DDGS in diets for weaning pigs appears to be okay, and in particular if the same producer produces weaning pigs and growing finishing pigs, it will be no problem that the pigs are a little bit lighter getting out of the nursery because they will compensate in the growing finishing period. However, if a producer is selling feeder pigs, it may not be economical to have that reduced weight, so that should also be taken into account. Finally, we've seen that if pigs are fed distillers dried grains with solubles from weaning, they will compensate for reduced performance in the nursery when they get into the growing finishing phase, most likely because they are used to greater bulk of the diets that is caused by DDGS, and therefore they have a greater digestive tract, and therefore they can consume more feed during the growing finishing period, as we saw in some of the experiments. So overall, there appears to be very little impact on overall performance from weaning to finish if we add distillers dried grains to the diets, and up to 30% appears to be just fine in growing finishing diets. So with that, I would like to acknowledge all my students and technicians, postdocs who have helped conduct this research. We have a group of very enthusiastic students at the University of Illinois, and we would not have been able to conduct this research had it not been for these students. I do want to acknowledge that. Finally, if you want to learn more about what we are doing in the Monogastric Nutrition Lab, please visit our webpage at nutrition.ansi.illinois.edu. All our research reports, all our newsletters, all our presentations are on this website, and you'll be able to see what we are doing. Thank you for your attention.